students and professors. This is Pablo and Justice here. Today we will be talking about vector functions, velocity and acceleration, section 12.1 to 12.3. So first, what is a vector function? A vector function is a function that describes the position of a particle in space. The domain is time, which is determined by the function, and the range is the vector and the position along the curve at any given time. Class, attention please. What are some of the uses for these vector functions? We can use it to represent the motion along the curve and to trace the graph of a curve. For example, we have this function, t cubed I plus t squared j, where t cubed I is my x component and t squared j is my y component. At any given time, we will have a unique vector for this function. So at time 1, we will have 1 and 1, 2, 8 and 4, and at 3, we will have 27 and 9. We will graph this to show you what it looks like. Something like this. Now that you have a brief description about what a vector function is, my friend Justice will explain to you what's velocity and acceleration.
Professor students. My partner Pablo explained to you what a vector function is. He gave you an example. Now, if we say that this vector function is our position on curve, we know that when we have a change in our position over any given time, this is known as a rate of change. And the way we describe that rate of change is velocity. We can also say that velocity is the first derivative of our position function. An example would be if we start with this position function and we take the first derivative, we get 3t squared I plus 2tj. Now, if I wanted to find, let's say, the velocity of my position right here at t equals 1, what I'll do is, I'll say, okay, time is 1, so I know my velocity function at 1 has to be 3, 2. Now what I'm going to do is, I'm going to come here and go up 3, go across 2, and from this point all the way up here, I'll say that's velocity. Is that okay so far?
Yes.
Thank you. Now, if we have velocity, we know that we must have acceleration too. And what we describe as acceleration is our change in velocity over a certain time. What we can say this is also first derivative of velocity or second derivative of our position. An example would be if we use this function right here for velocity, maintaining the same position function, we're going to say our acceleration is going to be 6ti plus 2j. And let's say if we continue with the same time 1 from our original position function, what I can do is I can plug that in, no problem, and say if t equals 1, acceleration has to be 6.2. Everybody with me so far? What I'm going to do is come over here and go up 6, across 2, and say this line right here has to be acceleration. Everybody with me so far? You want to try another one? Here's the graph of our position, velocity, and acceleration. Do you get it? Say yes.
Yes.
You want to try another one? You guys need a break?
Yes,
Alright,
please.
take a 7-minute break.